Hi, my name is Des Martin. I'm the program coordinator at NextWave STEM, and I'd like to thank you so much for joining us for another one of our free PD webinar series, Mission to Mars Project-Based Learning Overview. I'm really excited because this is an opportunity for us at NextWave STEM to really support you as educators, to pour in a little bit, considering how much you as a community have helped us at NextWave STEM, especially when it comes to emerging technologies. We understand that the times are extremely weird, very strange, and we're in a position where many of us are doing hybrid education, remote education. And in that format, it can be really difficult to keep our students' imaginations captured, especially if we had some really exciting goals for STEM this year that we aren't able to do in quite the same way. Today, we're going to talk about project-based learning generally, but really project-based learning with a view towards Mars specifically for our students. It may sound like a pretty big lift. It may seem like something that's difficult to accomplish, but believe you me, you are able to do it for your students, both hybrid and remote. And we're here to kind of get you pointed in the right direction. So the first thing I want to do is talk a little bit about who we are at NextWave STEM. Many of you may be familiar with us already. For those of you who aren't, we are a startup. We are in year 3 of operation, and in the 3 years we've been in existence, we have seen tremendous growth with respect to our work with schools and with students. We started out in Chicago, Illinois, serving 6 CPS schools and after school programs. And in that time, we've grown to over 70 schools, worked with thousands upon thousands of students. At this point, over 7,000 students. We've worked and trained over 500 teachers in our professional developments, and we've also developed and licensed courses. So there are courses being taught around Chicago and in the near future around the country in our courses in emerging technology. That's 3D printing, drones, artificial intelligence, and robotics. And the courses are really critical. The work that we do is critical because we know that the world needs some really dramatic solutions in the future. And many of those solutions can't be attained without the application of technology. But we won't be able to see those solutions if students don't have those technical capabilities. It's really critical that students as young as kindergarten start to get hands-on experience with emerging technologies. So at Next Wave STEM, we believe that you as an educator are completely able to do that. Nothing that we're doing is rocket science, even if it is rocket science. You can do it, and we're here to support you with the curricula, with the training, and with the equipment. Really, more than anything, we want to empower you as educators to prepare students for a future that they may not even be able to imagine. So we've got a couple of goals for today's webinar, 3 things that we want to help you achieve in the time that we have together. The first is that we want to create a framework for a driving question in a STEM PBL. That's going to be an experience that's going to be really important. The really foundational thing that happens in project-based learning is exploring what that driving question is going to be. And Mars exploration is going to serve as a foundation for us during our webinar today. The second thing we want to do is connect those project-based learning components to some student teacher-driven activities. We want to start with the things that are student-led because project-based learning work differentiates itself from traditional work in that the students are really able to guide the experience based on their interests, based on their activities, based on their learning styles. We want to talk about ways in which you can collaborate with your students in some really powerful scenarios. And the third is that we want to build a framework for what your students will have to know in the prerequisite in order to expand upon the PBL. You'll find really quickly that as students continue to dig and go down further rabbit holes, that they may start to outpace their own understanding. So it becomes necessary to work with our own curricular development, but also scaffold up to where our students want to go to reach viable solutions in the project-based learning. Really fun, really challenging for both you and students. It shifts the paradigm dramatically for what our students are able to accomplish in the classroom and what we're able to provide for them as teachers. And we may actually be able to make a couple of rocket scientists in the process, which is a really, really cool prospect. So a great place to begin is really at the beginning. And we want to think about project-based learning, both of what it is, but what it isn't. And the reason that we want to do that is because many of us, all of us, are working on projects all the time. We've been doing them since we were young. But this idea of project-based learning, and for some of us, defining that as problem-based learning, it's important to understand that it has a very, very traditional methodology or a very different methodology than what we would see traditionally in our classrooms. So what is project-based learning exactly? A great place to begin is just with a formal definition. Buck Institute of Education for PBL defines project-based learning this way. Project-based learning is a teaching method in which students gain knowledge and skills by working for an extended period of time to investigate and respond to an authentic, engaging, and complex question, problem, or challenge. Lots and lots of content there in a very short amount of space. Suffice it to say that the most important part of project-based learning is that students are spending an extended amount of time and they're being investigatory. This isn't the kind of thing where we're setting our students up with worksheets or they're doing rote mathematics or they're just learning formulas with no basis in reality. We're setting up something that is going to take up a unit or potentially multiple units of our classroom instruction and is designed to really explore and ask for solutions to something that's real, something that's fun, something that's complex. Um, it kind of changes the way we even think about our curricular design and our lesson design. So it becomes this really powerful experience that we can build in for our students. And many of us have already begun building in for our students. So just for a little bit of history, I know that this sounds like something that's new, something that's really been in the zeitgeist in the recent history when we think about education. But project-based learning is something that we have been doing deep into antiquity. When we think about PBL, there's no one person who invented it, but we can trace its origins, even from Confucius and Aristotle. We think about ancient Greece and Hellenistic learning models. They were advocates for learning by doing, really getting hands on. Staying with those ancient scholars, Socrates believed in learning through questioning, inquiry, and critical thinking. It's not just enough just to apprentice and repeat, but to really ask some questions and think critically about how different applications can be derived from the tools that we're working with. John Dewey, now that we're coming into Europe, into the New World, believed in learning that was grounded in experience and driven by student interest. Once again, it's the idea of learning by doing, but not doing just any old thing. It's doing those things that bring excitement and bring engagement to our students. Um, Things that will make them authentically want to be in the classroom with us. Maria Montessori. Some of us are Montessori educators, and we want to give a huge shout out to our Montessori educators because a lot of the Montessori tradition of student driven work refined and project based learning as well. It's so important that our students have a voice in their own learning. They will care about what they learn. They will apply what they learn if they choose to learn it. If they authentically want to be in the classroom and experiencing what the classroom has to offer, it's important that they have a voice, that they have a choice, but that we also create safe, relatively safe, I should say, relatively safe opportunities for them to fail. That means that there's that extended learning opportunity even in their failures. And then we have, once again, those New World thinkers, Jean Piaget, me coin this idea and really explore the importance of making meaning from our experiences, failures, good and bad. times when we're bored, times when we're extremely engaged. It's important because we learn not just the subject matter, in our case, science or technologies, but we also learn about the processes with which we work in the world and others work in the world. Um, Project-based learning has the potential to do all of that for our students. So when we think about project-based learning, we have a sense of the roots, we have a sense of the history, but we also want to understand more about the actual learning model. What does project-based learning look like? And we can really think of it as a six-step process, boiled down and distilled into varying events. Really, really powerful stuff when we dig into what each event entails, especially when we start to draw out our learning paths and our learning trees, what our students might actually end up doing in the classroom, the places where student voice and choice and our voice and choice when we think about curricular design. Um, but the learning model can be broken down into these six steps. Um, Formulating our driving questions, conducting inquiry and research. Once again, now engaging the student choice, um, project design and feedback on the design from the instructor or instructors. We see this amazing cycle of feedback and input and feedback from student and instructor. Presentation, where the actual solution, the challenge is answered, the end user is considered and actually tests what our students have made. That comes into effect. And then we have the reflection, the capstone where we think about the entire process, think about the solution, how well it went, get feedback from our instructors, um, the culmination of all these different accessible moments. Project-based learning really allows us to capture all of that. So to make sure I don't skip ahead, project-based learning is really different than what we think about with a traditional project, once again, where those projects are considered more of a dessert than the actual main modality of learning. We think of launching a unit, doing a rote activity, a lesson, an activity, a lesson activity. You may throw a quiz in here or there that are formative assessments. Sometimes there may be a test that's a summative assessment before you move on to a new unit. But then we do this back and forth dance and then kind of throw the project in at the end. We're scrapping this model and going to something completely new, or not even completely new, but very different than what we've done in the past. So when we think about a project-based learning unit, this is a really great example of what we can think of as the events. Those actual things that we as instructors will control, places where students will have their voice and choice really represented as they move through a project-based learning unit, and those reflective moments that may also be assessment moments. When we think about how students move through this is not hard and fast locked in. You'll see that the project launch really gives us the context for everything that's happening. Um, that's really instructor driven, instructor to students. When we think about the actual chevrons there that are in blue, things like activities and workshops and lectures, those things are student work, they're student driven. We may empower them with the correct rubric and tools for the ability to understand those activities. We may rely upon their prior knowledge, their prior skill set based on how old your students are, what grade level they're at. But that's where they're really digging in doing the work. We benchmark. We say, okay, have you moved far enough in your project? Have you developed a tree and a path to get there? Are you asking the right questions to think about what your next step is going to be, your next student driven activity? And then when we get into the reflection, those are our assessment moments where we look at the work that they've done and give that feedback and say, okay, this is where we expect you to be. This is where we need you to be. These are the places where the choices you, or we may limit and pitching you into some different activity choices based upon what we saw with the last round of student lab work that you did. So we're guiding them. There are some triggers that we can build into project-based learning, but we want to make sure that this higher cycle is of students' opportunities to guide the project themselves, to allow them to really keep that interest as they're doing the entirety of the project. And the goal, once again, is to give them the opportunity to grow in their investigative practices. Are they learning how to ask the right questions to get towards a solution? Are they learning how to choose a student-led work that's going to build their skills to answer those questions? And can we set those benchmarks up? Can we set the reflection feedback up in such a way where we're getting them where we want to be? That is really where the secret sauce lies when you think about project-based learning. So we discussed like the big framework, history and framework of project-based learning. Now the question becomes the question. How do we choose a driving question? What is that thing that we are going to use as the linchpin for a nice, beautiful, longitudinal project-based learning experience for our students? Well, in this case, we want to use something that we know is exciting. I will confess I am a mechanical engineer by training, but before that, I was just your run of the mill nerd. And your run of the mill nerd loves things like Star Trek. Um, Traditionally, when we explore and use project-based learning, we want to create a context in which our students really understand or are excited, things that are happening around them, things that are happening in their classroom or in the school, and maybe a big national conversation or international conversation. And as we consider those things, we're asking some questions and getting feedback from our student. What's the problem that currently exists? What are the tools that we have available to solve those problems? How can we make sure that the problem is actually getting solved for the person who has the problem? But when we think about Mars exploration, we're setting up this really exciting beyond moonshot problem. This question of how can we get to Mars? How can we explore Mars? How can we go someplace that we've never been before? How can we experience some of the things that we'll see in movies and on television? How can I have the communicator like I saw Captain Picard using in Star Trek? And how can we get from where we are right now to that place? That really becomes the place where we center this particular project. It's fun, it's exciting, it's engaging. It sounds like science fiction, but it's science fact because we don't have to get to the end of our PBL with the USS Enterprise designed. We can really learn more about the work that's been done and think about and ideate and design for solutions that we can participate in right now. So, what do I mean when I say solutions that we can participate in right now? Well, it's important to understand where we currently are in our science, where we currently are with our technology, where we currently are with our engineering. In order to interact with the real world problem, we need to understand what's happening in the real world. So that's where we start with a foundational knowledge of science, understanding what's happening in the universe around us. There are some simple facts that our students may not know. There are some simple facts that we may not know about what's happening scientifically. Um, for example, what you're currently seeing is a computer generated model, an actual illustration that Mars developed for the InSight robot that landed on Mars almost 2 years ago at this point. The InSight rover, for those of us who aren't super familiar, is the fourth robot that we successfully landed on Mars. And the entire purpose of this robot is to measure seismic activity, to measure how much Mars is shaking and moving. We have this idea, we have this question: is Mars seismically active? Is there magma that's moving underneath the surface? Is there water that's moving underneath the surface? How can we measure that? How can we know that? Well, that raises another really important question. How is any of that relevant to what we're doing here on Earth? Well, this gets into this bigger question that we're having. Do we understand enough about our deep history, our deep past, and our future to be able to live on Earth successfully? Um, are we going to learn more and more about technologies that allow us to travel through space that we can apply other places? Things like global positioning systems, and Velcro. We invented those things because of our desire to want to go and explore the moon. Um, and can we apply some of the solutions that we have now in order to explore in space and make better solutions for here on Earth? A perfect example of this is that Mars rover flying out to Mars, flying through space in a rocket, then eventually flying through Martian atmosphere, has got to be an autonomous vehicle. We cannot control that by a remote control from here on Earth. And the reason why we can't control it from here on Earth is that Mars is literally millions upon millions upon millions of miles away. Mars is so far away that we are now having to think about the speed of light. When you remote control something here on Earth, your radio signal, your Wi-Fi signal travels from your antenna to that device at the speed of light. It's instantaneous here on Earth. But through the vacuum of space, it's going to take a little bit of time because of how far it is. In fact, it takes a signal to get from here to Mars on a good day, where things are lined up really, really well, about 8 minutes. And that's 8 minutes both ways. So if I made a phone call out to Mars and you picked up the phone, I would start speaking and you would just be holding the line. 8 minutes later on, you would hear what I said, and vice versa. It takes another 8 minutes for what you say to get back to me. For us to be able to control some kind of device remotely, flying through the air with that kind of delay is impossible. So the drones, the robots, they will have to control themselves. We have robots that have been rolling around Mars for a couple of decades now, um, in large part controlling themselves, and we're sending flying devices, things with parachutes and helicopter blades that are going to be flying through Mars. That's why when we think about project-based learning, when we think about the kind of solutions that we can design for Mars, a great, excellent first place to start is with drones. How can we actually get there and move around? We have to design something that will be able to follow a set of instructions and move by itself. So that's a little bit of background scenario, but we already see there that the scientific knowledge, the basis, the understanding of what drones are, the earth science and space science understand the speed of light, to understand distances, to understand how electromagnetic waves work. We have all this foundational information and knowledge that has to be laid before we can even start to develop solutions for our question. And all of that foundational knowledge becomes a great way to build in those learning opportunities, those student-led and teacher feedback moments in project-based learning. We don't think of these necessarily as impediments. We think of them as add-ons to our learning unit. So there's no such thing in almost all scenarios as losing through the course of a project-based learning experience. So that question, we say, okay, we want to explore Mars. We want to get a jump on getting to the red planet and moving around and learning more about the red planet. Where does our student work go from there once we have established this driving question? Well, for us at NextWave STEM, it's about integrating the new technologies. And integrating the new technologies into these scenarios is really important, becomes super useful when we think about what problems we want to solve once we're on Mars. Two technologies that I keep coming back to over and over again because they're so vital. They're vital to what we do at NextWave STEM, but they'll be vital to what we do in space generally and on Mars specifically, is drones and 3D printing. Our students, once again, are going to be investing in those student learning opportunities and those activities to explore computer science, math, and engineering when we think about drones, but also in 3D printing. They'll need to learn how to make a drone fly by itself. They'll need to learn the computer science in order to give instructions to the machine, in this case, the drone. They'll need to learn how to simulate drone flight. They'll need to learn how to apply it to different scenarios, whether it's taking pictures or using a sensor to take samples or using the drone to simulate construction application. And the great thing is that this is not disconnected from the real world. It's not just simulation. They're able to take what they're simulating on their computers and connect that to real drones to simulate with a real life drone. So we're doing the things that NASA would actually do. Before they ever went to the moon, back in the late 60s, you had astronauts training in secret in the desert, exploring what it'd be like to wear a spacesuit and move around extremely rocky and desolate scenarios. This whole process of testing and building facsimiles has become so important. 3D printing is going to be critical when you think about Mars exploration, because getting things to Mars is extremely difficult. The reason why we've never sent a human being to Mars, we've never even attempted to send a human being to Mars, is because with our technology today as it stands, that would be a one-way trip. We would send people. We would not be able to send them with enough food. We would not be able to provide them space. We would not be able to provide them lodging on that rocket. It'd be too big and too heavy. We couldn't even get that rocket off the face of the earth. But let's say we just put a person on a rocket and sent them to Mars. Well, assuming that they keep their sanity along that 6 month trip and that they don't starve and that they don't suffer death via dehydration and that they land and they survive the landing, we then have no way to get them back from Mars to the Earth. So it's important that we send some technologies up there with them that will allow them to actually live. Can we design 3D printed homes for them on Mars? Desmond, you said that we can't transport their housing. You're right. What we would have to transport is the machines to do 3D printing and use the material on Mars as our 3D printed material. Can we take Mars dirt and transform that into a malleable material that we can 3D print into a house, kind of like what we see in this picture? Um, Things going through the engineering design process, understanding material science. Some of this may be beyond where students are at to be able to come to a solution, a really workable prototype, but we get them started and pointing in the right path. And once again, we're going to be prototyping and modeling. And so they may not ever 3D print an entire house out of dirt, for example, some things that scientists are working on right now, but what they can do is connect to your 3D printer and print models, real models of what they designed and compare and contrast their actual design properties. Can we simulate using a fan or a leaf blower, a Martian storm and see whose Mars blows over in that wind scenario? Simulating, designing, exploring, and thinking about what our students will be able to expand upon later on with this project-based learning experience becomes a super, super powerful experience. So when we think about student-led work, we keep mentioning all these different things our students are able to do when we think about project-based learning. In project-based learning, student-led work, these are just examples of all the things that our students are able to do. Um, those activities, for example, may be guided activities with you as the instructor, thinking about 3D design, for example, specific models. How do I get a perfect curvature if I want to design a dome? How do I augment the design of a dome in a 3D model? There may be workshops where you bring in experts. They may be aviation experts, 3D printing experts, different people who have extreme expertise in the technology that your students are going to be working through. Some of it is going to be good old fashioned homework and research from your students. Can they go in their digital skills to look up information about NASA, about Mars? You as an instructor may be doing that homework as well to grow in your skills. But once you get through that benchmarking and reflection section, we're getting into a new set, or maybe even the same kind of activities where we're simulating flight or constructing and printing. We may be interviewing scientists or astronauts or researchers. We may be doing some really intensive reading to think about why we want to go to Mars in the first place. We may even have activities that have us questioning our project launch and our drive question and our driving question and have to interrogate and negotiate that. The question might come up, hey, how much is any of this going to cost? Are we spending so much money on trying to go to Mars and trying to live on Mars that we could be applying to other places? Questions about civics come up, and we'll need to explore that. There is so much that we can do here with our drones, with our 3D printers, and integrating other technologies into our PBL work as well. So lots and lots of information, a little bit quicker webinar today, a little bit quicker of a PD session today, but we want to make sure that you got this foundational framework with which to begin. NextWave STEM, we are really intentional too about making these webinars available, but also letting you know more about what we can do to support you directly as educators. The first thing that we can do and that we're really excited to do is to continue this webinar series that we are working through now. You're already here, so you already know about our webinars. Right now, they are going in each Tuesday at 3 p.m. Central Time. They are free. They're going to stay free. And we are doing this really with the thought of making sure that there's resources for you to grow in your abilities. NextWave STEM is also really happy because I mentioned before that we offer licensing options and not only licensing options, but instructional options. We are doing instruction in classrooms in 2 formats, a hands-on experience so that if you are remote, your students are distance, we can send the equipment to your students or to your school for material and equipment pickup and drop off. That's something that allows your students to get hands-on with STEM at home. But we also are doing virtual instruction. That's our certified STEM instructors teaching your courses both in school time or out of school time. You can click this Learn More button when I share the slide deck with you after our webinar today, or email us at hello@nextwavestem to learn a little bit more. And then thirdly, there are the curricula that we're licensing. K through 12 in robotics, drones, 3D printing, and artificial intelligence. This is super, super exciting for us to be a resource for you, to provide you curricula, equipment, and training so that you can offer STEM in high fidelity. We love that opportunity at NextWave STEM, and that's something that we will continue to do in the future and want to make a great product for you. And so I want to pause because we had a lot of material that we covered and just leave it open for questions. Are there any questions that you might have about anything that we've covered in our webinar today? And I'm just checking through our participant list just to make sure that if you have any questions, you can ask them. Our Q&A functionality is also open, so you can use that if you just want to keep your questions discreet as well. Well, we don't have any questions right now, but if you do have any questions, I would love to hear from you. I love questions. I love getting into the weeds with educators. I'm Desmond Martin. Once again, the email is really easy, desmond@nextwavestem.com. And you can also locate us on all major social networks as well. That's Twitter, LinkedIn, Facebook, and Instagram. We're located under that @NextWaveSTEM handle. So connect with us. We'd love to connect back with you. We can share some really interesting things that are happening in the world of emerging technologies. More than anything, I want to thank you so much for joining us this Tuesday afternoon. We're hopeful for all that your students are doing this year with emerging technology. Ooh. Oh, I got a question here, kind of lit question here. What about people in Denmark signing up to go to Mars? Mary, I heard about this. This is kind of a interesting private effort. The goal is almost kind of like a crowdfunding idea that really well-heeled individuals would help this particular company work together and do these one-way trips to Mars. They are people who want to go to Mars, and no matter that toll of human outcome, want to say I was the first to do it. Um, I am not of the opinion that going and knowing that I'm not coming back makes that worth it, especially given the fact that that reporting, that information, that data that we could send back about Mars, um, honestly, other than the emotional, raw human feeling, okay, this is what it feels like to be in space for 6 months. This is what it feels like to see the red planet. We're not getting back useful information about Mars that we can't get back from robots right now. We've got satellites around Mars. We've got robots on Mars. Are humans better than robots at gathering and sending information? In some cases, yes. In some cases, no. Do I think it's worth killing a person to be able to get that information? Definitely not. Um, or I should say, definitely not on purpose. I think the history of human exploration says that people will take risks, calculated risks, to be able to do amazing things, to be able to do things that make our world better and make the lives of human beings who live there. But if you're doing it and you know that this is going to be something that kills you, and you don't know whether or not what you're doing is going to make a difference for humanity, that sounds like it does not pass the criteria for taking that trip to Mars. It's actually something that is more of a passion project, lots of vanity wrapped up in that, if I'm being really frank. I think that also speaks to the level of ethics that we have to continue to embrace when we think about scientific exploration and the actual application of what we learn in STEM fields. And this is something that I would love to explore with students. What we consider to be right and wrong when we think about exploration, going to Mars, the pros and cons. These are conversations that our leaders have to have, our STEM professionals have to have, and we need to have with our educators. Yes, David Attenborough says that he'd rather fix this planet and enjoy flora and fauna on Earth. I agree. Um, if if in the world there is limited finite resources, which is true, and when we think about those limited and finite resources, if going to Mars or going to the moon or launching another satellite keeps us from fixing problems that we have created here on Earth, then in my mind, we should not do those things and do the things that need fixing when we think about ecological damage here on Earth. That's where I stand on that. Now, the interesting thing about that question is I think sometimes people see the pursuits as equivalent. When we think about the budget of NASA or a Mars mission or a moon mission or a telescope mission, it is such a small fraction of the budget that we actually expend on everything else that we do here on Earth to destroy the world and to make the world better. If somebody says, okay, we're spending too much on NASA, I say back, you obviously have no idea how much we're spending on NASA. We could not engage in an armed conflict. And for that armed conflict that we do not engage with, we save money to fund NASA for literally decades. And the return on investment um, is is ridiculous. It's really telling. Um, but I'm not a policymaker. Um, I speak to my policymakers when I get the opportunity. I send those emails and I send those letters, and I encourage you to do the same. That's something that's definitely worth exploring when we think about science education, but also civic education. But that's just me stepping off of my soapbox a little bit. That's all we have for you all today. Thank you so much for joining us, Mary. Thank you for that awesome question there at the end. When we think about the ethics and what's going on in the Mars space. Email us at nextwavestem.com, Desmond at nextwavestem.com. We'd love to get into it with you some more. But until then, we're hoping that you have an awesome, healthy rest of your day until we see you again next week. Have a great day, everyone. Bye-bye.